Hello, thank you for watching this video here for a little extra help on solving 3x4 systems with 3 variables. So what we're going to do is take a look at how to solve, you're going to take a look at how to solve x, y, and z now rather than just x and y. So we're looking for the point in three-dimensional space where these actually three beautiful planes would cross. So we're going to add in the element of the z. So kind of run through the steps real quick that we're going to go over. We're going to pair up two equations and eliminate a variable. Then we're going to pair up two equations and eliminate the same variable. Then we're going to bring them together and eliminate something else. Then we're going to solve and substitute back into answers 1 or 2. And then we're going to solve for the other variable and plug it back into one of the originals to get the third. So there's lots of eliminating and lots of substituting. So let's take a look at solving this system here. So you can see that we have the xyz, xyz, xyz. There's three equations here. And our first step is going to be to pair them up and eliminate something. So it doesn't matter how you pair them. I think I'll pair the top one and the middle one, let's say. So negative x plus y plus 2z's equal 2, and 2x plus y minus z equals negative 4. I'll pair those two up, and then I'll make a decision about who I want to eliminate. Let's say I choose to eliminate x. So that means this one I will need to multiply by 2 in order to make that elimination possible. So it will become negative 2x plus 2y plus 4z equals 4. 2x plus y minus a z equals negative 4. And then if I go ahead and add those two things together, I'd get 3y's plus 3z equals 0. So I'm going to go ahead and put a box around this. This is an important step in our work. What we've done is taken two equations that had 3 variables and turned it into one equation with 2 variables. That's an important part of our process. So what we did is, again, we paired up the top one and the middle one. We haven't done anything with that third equation. So step 2 is going to be to pair him up with somebody and eliminate the same variable. So we decided to eliminate x's the first time we paired up. So my third equation is x plus 2y plus 3z equals 2. We're going to want to eliminate x's again by pairing him with somebody else. Well, it looks like if we paired him with the top one, the very first one in our list, that the x's would eliminate right away. That would be kind of nice. So if we go ahead and add these two together, this is the first one and the third one, we can see that we have 3y plus 5z equals 4. So what we've done again is taken two equations that had 3 variables and turn it into 2 equations with 2 variables. Now these boxes here are very important. We're going to take these two things and look at them together now. So 3y plus 5z equals 4, and then 3y plus 3z equals 0. These are the exact same two that I boxed on my previous work, 3y, 3z, 0. And what we're going to do now is eliminate something else. So once we look at those two side by side, we want to eliminate something else here. Well, it looks like my y's would be pretty easy to eliminate if I went ahead and multiplied maybe the top one by negative 1, let's say. So it becomes negative 3y, negative 5z, and then negative 4. And then my bottom one becomes, again, 3y plus 3z equals 0. So I'll go ahead and add these two things here. I'd have negative 2z, negative 4. So z becomes positive 2. See how I went through those steps there to take those two equations together, added them up after I made something else eliminate, and then we can go ahead and solve for that variable. Nice. So now that we know that we have z, we now need to substitute that back into our work to solve for another variable. So remember the two equations were right here that we brought together. We need to take that z of being a positive 2 and plugging him back in to find that y. So if z is a positive 2, Let's stick him, let's say, maybe right in there. 3y plus 3 times 2, 0. So 3y plus 6 equals 0. I'll subtract the 6. 3y equals negative 6. So y then would be negative 2. So now we know z and we know y. So we can go ahead and use those two facts. Z is 2, y is negative 2. Z is 2, y is negative 2, and now we can take those facts and plug them back into one of these three original equations. Maybe I will stick him into this bottom one down here. Both of those can get stuck into that, and we'll solve for what's left, which is the x. So x plus 2 times the y number plus 3 times the z number equals 2. X minus 4 plus 6 equals 2. So this is x. If I combine those like terms, that's like x plus 2 equals 2. We'll subtract 2, subtract 2. So x is 0. So we now know the x, the y, and the z. And then my final solution I would write as this. This is the x, this is y, and this is the z. So those are the steps that we go through to solve a 3 by 3 system. So 3 variables, 3 equations using elimination.